Hi, ladies and gentlemen. I hope everyone is doing well today. Today we're taking a look at acid-base applications in the Unit 12 chemquest packet. So right up top we start off with some information about common acids and bases. So on the left side we have all our acids, on the right side we have all our bases. It reminds us that acids have a pH less than 7 between 1 and 7. Bases have a pH higher than 7 between 7 and 14. If something is 7 exactly, then it is neither acidic or basic, it is neutral. So question one is asking us, what do all the acids in the table above have in common? So focus on the formula. What is present in all of the formulas of the acids? Question two, very similar, except this time it's asking about bases. So this time look at the bases side. What is present in all of the bases formulas? Question three. Question three is asking us about a solution that has a pH of 2.75. They want to know what the solution is probably made out of. So our pH of 2.75 means it's acidic. So which one of these down here is an acid? Question four. Question four says a guy has a pool. Whenever you have a pool, you need to manage the pH. That way it doesn't damage your skin when you're swimming in it. So he already knows that his pH is a little bit too low. So he wants to add some H2SO4 to it to try to fix the problem. Remember, guys, H2SO4 is sulfuric acid, which means it is an acid. So would adding an acid to something that already has a low pH, would that raise it? Remember, you can look up here to see what the pHs of acids usually are. Question five. So question five is talking a little bit about acid rain. So it happens typically because factories let out the pollutants like sulfur oxides and nitrogen oxides. So I highlighted these to remind you guys that sulfur oxides are typically things like sulfate, SO4 with a -2 charge, and nitrogen oxides are typically things like nitrate, NO3 with a -1 charge. So think about it. When these are combined with water, what forms? And that is why acid rain happens. Question six. So question six is pretty important. It gives you a lot of information, so I ended up highlighting most of it. So the first sentence is a little bit of a refresher. It reminds us that acids and bases react together and they neutralize each other. So then now is what comes some of the new stuff. An acid will react with a base in a double replacement reaction. When an acid reacts with a base, water is always one of the products formed. So what we essentially need to do is subtract out water and then figure out what's left over and then combine those to make the new the last product. So that's what we start. We start with HCl and NaOH. So we combine them together. So when we look at water, water is two hydrogens and an oxygen. So where could those come from? So we know a hydrogen is going to come right there from the HCl. We also know that the other hydrogen, the last oxygen, has to come from there, from the OH. So then what we have left over is a sodium and a chlorine. So then we just need to remember our rules when we combine these to make our last product, which ends up being NaCl. Remember, guys, whenever you combine, you have to remember to crisscross. So we have sodium with a +1 charge. Chlorine has a -1. Remember, guys, those charges just come from the column it is in the periodic table. So when you crisscross, it just becomes NaCl because the charges are both 1. So question seven is now writing the reaction for what happens when you combine nitric acid and calcium hydroxide. So I wrote out nitric acid and calcium hydroxide for you. I got you started because remember, it's always going to form water. Then we can look and see how we take out the water from the formula. So it's very similar to the one up top. The first hydrogen has to come from the HNO3, and then the last hydrogen and oxygen come from the calcium hydroxide. So what's left? When you combine these two, remember to make sure to crisscross the charges. You can find the charge based on the periodic table this is located. Remember, calcium's in column 2. Nitrate, you can look up on the back of your periodic table if you don't remember the charge. So next, question 8. Question 8 again gives us some new information. So whenever compounds that contain carbonate react with acids, it will always form carbon dioxide, water, and another compound. So immediately when we see these two blanks and we see the other compound, we know that we can put carbon dioxide and water there. So again, we need to try to figure out where the carbon dioxide and the water comes from. So we know there's only one hydrogen. So we know that that hydrogen comes from, will help form a part of water. And then we know the only other place that we have, so we have carbon dioxide, will come from carbonate. Don't be mistaken, it doesn't come from over here because it's bound to nitrate, not a carbon, so it's not carbonate. So two of the oxygens and the carbon will form carbon dioxide, and then one of the oxygens will help form water. So then we look and see what's left. We have calcium and nitrate. So we need to make sure to crisscross these charges. Calcium has a positive 2, nitrate has a negative 1. So we crisscross. It becomes CaNO3 2. So then the last step would be to balance this reaction. So you would look over on this side. I immediately notice that we have one more nitrate on this side than on the other side. So all we need to do is put a 2 in front over here. Then what that does is that makes us have 2 hydrogens for our water. It also makes us have 2 nitrates for our calcium nitrate. So again, guys, part B, I'll get you started. So we know that it's going to form carbon dioxide and water. So the carbon dioxide and the water come from the same place. It comes from the carbonate ion. So there's the 1 carbon and 2 oxygens go there. And then it comes from the hydrogen comes from the HCl. So we know that the H goes there. And lastly, we need to figure out and make the last product. So you have a calcium and a chlorine left. Make sure that you crisscross the charges. Don't forget to balance it. When you balance, look at how I balanced A. It's very similar in B, and it's also very similar in C. So part C, I'm going to let you guys do alone. Remember what always forms. Where do you subtract them out of, and then what would be left to make the last compound. Question 9. So question 9 is talking about limestone at the bottom of the lakes. It tells us that limestone is primarily calcium carbonate. Remember, it doesn't have a hydrogen coming in front of it, so it is a base, not typically a base. So why do you think that limestone is not affected by acid rain? Give your best hypothesis. The information that we highlighted in 6 and 8 will be helpful when you are thinking about this question. So lastly, now we come down to some skilled practice questions. So this is now using what we learned in previous chemquests and previous units and tying it together. When you do these, you have to show work to receive credit. If you do not show your work, I will ask you to show me your work before I give you credit for it. So question 10. Write the balanced equation for hydrobromic acid and calcium hydroxide. So whenever you need to look up acids or bases, check here first. They are most likely on the front for you. So you can actually find those 2 on the front, and then you can do out the reaction. Same thing with 12. You'll be able to find nitric acid on the front. It's an eraser thing. On the front table. Question 11. So question 11 is talking about vinegar, acetic acid with the baking soda reaction, and tells us lots of bubbles are produced. So remember, guys, this is very similar to the lab we did. So you should be able to figure this out. You'll be able to tell based on how stuff reacts, what the formula for baking soda is. You'll be able to tell what bubbles mean. And then you can think about the formula for not the formula, the pH for baking soda. Using the formula that you get in part A will be helpful because you'll be able to tell whether it's an acid or a base. Questions 13 and 14 are very similar, or not very, they are questions from the previous unit concentration. So we are going to use our molarity formula, moles over liters. So remember, guys, make sure you convert your grams to moles, and then make sure you convert your milliliters to liters. Remember, we do that by dividing by 1,000. Question 15. Question 15, it's asking about the ion. Remember, anytime it asks about the ion, we have to dissociate, balance the coefficients, and then use the coefficients to figure out the new concentration. 16, 17, and 18. These ones you'll be able to find in the previous chemquest, pH and POH. There were many problems very similar to these that you can base your work off of. Remember, guys, if you have any questions, please make sure you circle them and bring them to class. Hope everyone has a good day.